So the atomic structure, we know that there's a nucleus. In the center, tiny, dense nucleus inside the atom. Okay, it's very tiny, very dense, and it has the protons and neutrons in it. And dense means what? What is density? Okay, what else? How can you define density or dense? How much mass something takes up. So why do you think the nucleus is so dense? Think about mass right now, what we talk about, the subatomic particle masses. No? It's so dense because most of its mass is there. Protons are 1 AMU, neutrons are 1 AMU, right? And the electrons, it would take 2,000 electrons just to equal 1 proton. And none of these atoms have 2,000 protons. Okay? So all of its mass, most of its mass, is somewhere inside that nucleus. That's why it's so dense. Yes? No, we'll go over that though. Okay? All right, and electrons, they have very little mass, right? So the rest of the atom has very little mass at all. Most of its mass is all in that tiny little nucleus. It's the heaviest part, if you will, of the atom. Okay, and again, just to review, orbitals are the path of electrons. Subatomic particles, we've discussed these all week. Small particles that make up an atom. So protons are the positive bit, neutrons are the neutral or no charge, that's why they don't have a symbol after it, and electrons have a negative charge. Okay? The nucleus is the center of the atom, which contains protons and neutrons. So copy that into your notes. So you don't have to write this down because we did this already earlier, it's just review. Electrons, they're tiny, very light particles. Their mass is only 1/2000. That's a very small fraction, right? 1/2000 of an AMU. It takes 2,000 electrons to equal the mass of only 1 proton or just 1 neutron. 2,000 electrons. Just equal 1 proton when you talk about its mass. Okay? It has a negative electrical charge and it moves around the outside of the nucleus inside the atom. Okay? They move around in what we call the electron cloud. Okay? Other models have used other things, but the modern day model discusses the electron cloud. All right? Talk about protons for a second. Much larger, heavier. They have a lot more mass than electrons. Their relative mass is 1 AMU. Okay? Relative mass means, and this is one of your terms you had to define, relative mass means that it's when you compare the masses of different objects to each other. Simple as that. When you compare the mass of 2 or more objects to each other. That's what we call relative mass. Protons also have a positive charge and are located inside the nucleus of an atom. Neutrons are a little different. They still have, what they have in common with the proton is that they are, again, they're very heavy, just like the protons. They have a relative mass of 1 AMU. They have no electrical charge. And when we say something has no electrical charge, we can also say that it is what? Neutral. Good. And then it is also located inside the nucleus of an atom. So relative mass. I'd like you to write down this bottom part where it says electron, neutron, proton mass, and atomic mass unit. Copy that into your notes just to remind you again what their relative mass is. Write that at the top of this. Relative mass. And we measure that in AMUs. Grams were too big. Even, milligrams. They were too big to measure the mass of these subatomic particles. So scientists came up with a smaller scientific unit of measurement called an AMU, atomic mass unit. Electrons are the lightest of the three subatomic particles. It takes 2,000 electrons to equal the mass of one proton. Okay, that's relating their mass to each other, relative mass. Electron's mass is 1/2000th of an AMU. Neutron is 1 AMU. Proton is 1 AMU. And AMU stands for atomic mass unit. Okay? So let's just take a quick look and remind ourselves the structure of an atom. Again, this is not the modern day model. This is Rutherford's model. And what do these black lines represent? Orbitals, right? Orbitals are the path that the electron takes around the nucleus. So the green represents what? Neutrons. The protons represent purple. Purple and green. Protons and neutrons. They're inside the what? Everybody?
The nucleus.
The nucleus. What kind of charge does the nucleus have?
Positive.
Very good. Then we have the electrons that are outside of the nucleus but inside the atom, right? They're surrounding the nucleus. What kind of charge do electrons have?
Negative.
Okay. So what kind of charge does the atom have?
Neutral.
Neutral, very good, because we have a positive part and a negative part, and what happens to those?
They cancel each other.
They cancel each other out or balance each other out, so we have a neutral atom. Okay, because we have the same, in a neutral atom we have the same number of what?
Protons and electrons.
Protons and electrons, excellent. All right.